We have a integral. Looks and not that easy, very complicated. You have a trig function, you have exponential function, you have a high power, and you have a rational function. So how do we start? Now, let me put this as integral I. I let x is equal to negative t. So dx is equal to negative dt. Okay, so this integral I is equal to e to the negative t. The cosine negative t is the same as the positive t. Therefore, this is a cosine cube t and negative dt, right? And over 1 minus 1 plus e to the negative t. Now, x is negative t, therefore this is become positive half pi to negative half pi. Okay, so far so good. Now this negative, I can change the limits, right? So this becomes a negative half pi to positive half pi. So this negative is gone. And this is a cosine is the same, cosine cube t dt. Now here I'm multiply e to the positive t, both numerator and denominator. So this becomes 1. This becomes e to the t plus 1, right? Okay, so far so good. Now since this integral, we can rewrite t for x, right? Because these are dummy variables. So this is a negative half pi to positive half pi, and cosine cube x 1 plus e to the x, right? dx. So these are the same. Now this is equal to I, right? I is equal to this. I also equal to that. Therefore, twice I is equal to positive half pi. This plus this, right? This plus this. So this is a common factor, x dx. The common denominator, this plus this, right? So with a 1 plus e to the x. So finally, 2I is equal to negative half pi to positive half pi cosine cubic x dx. You see, the function becomes much easier. Since the cosine is even function, right? Therefore 2I is equal to twice from 0 to half pi cosine cubic x dx. Okay. I have a video that dealing with this and sine x, the cosine x in nth power. Well, the conclusion is that, well, if this is this number is even, then we reduce the power by using the reduction formula. If this is the order, then we change the structure of integrand function. Okay. So let me continue here. I is equal to 0 to cosine cube of x dx. Now, since this is odd number, I change the structure. I'll do this way. This means cosine square x cosine x dx from 0 to half pi. The reason I'm writing this way, because this is nothing but d sine x. And if I can change this into sine, then I change the structure, because it's no longer being integrated with the x. That I'm integrated with respect to sine x. So, but this is equal to 1 minus sine square x, right? So it's from 0 to half pi. See, the integrand function has been changed. So it's no longer being integrated with respect to x. I'm integrated with respect to sine x. Well, now this is in terms of x. In terms of x, this is equal to this integrand is sine x, right? D sine x. This integration is 1/3 sine cubic sine. Okay, sine cubic x. This is from 0 to half pi. So this one is equal to 1. This sine 1. This equal to 1, right? Minus 1/3. And minus 1, minus 0, plus 0. So this one is equal to 2/3. So my integral is equal to 2/3. All right, that's the answer. Okay, it's not difficult. Now, I have another way to do it, a little slight different. Okay, let me copy the question again. This is I is equal to integral from negative half pi to positive half pi, 1 plus e to the power of x, and the e to the power of x cosine cubic x dx. All right, I did it, but this time I'm doing slightly different from the other method. What I'm going to do is here, I split this integral into two parts, from negative half pi to 0. And e to the power of x cosine cube x dx, 1 plus e to the power of x, plus from 0 to half pi is 1 plus cosine e to the x, e to the power of x cosine cube x dx. All right, I just split this integral into two parts. Now, I consider this is let me do this one separately, okay? This one minus half pi to 0. This is e to the power of cosine cube x dx, 1 plus e to the power of x. I change it, I assume that t is equal to negative x. Let replace x by negative t. So this one becomes this becomes positive, right? This becomes the same as 0. and this is a negative e to the power of e negative t cosine. Cosine negative is positive, same thing, no change, right? This is a negative dt. This is a 1 plus e to the negative t. Well, so far so good. Now this is negative. I switch this limit, right? Becomes 0 to half pi. Therefore, this negative is gone. And I multiply by e to the positive t. Okay, e to the power of positive t. So this becomes 1, right? This was nothing but t. This one is equal to e to the power of t. This becomes 1. This is negative is gone with the switching that limit. So this one is this. This one is this, right? Therefore, my integral I is equal to this one, which is this. Negative. Okay. This is a cosine cubic x. These are dummy variable. I can write anything, right? This is plus this. Because this is this. Plus this. Plus 0 to half pi plus e to the power of x cosine cubic x dx 1 plus e to the power x. Then I combine them together. These two, same thing, right? Same limit, which is from 0 to half pi. This plus this. This plus this. Common denominator, right? This is a 1 plus e to the power x. So cancel with that one. So the result is cosine cubic. Okay. See that we have. Well, I've done it just now, so I don't repeat. So this one is equal to 2/3. Right? Okay. This is another way, which is slightly different from the first one. See, this integral looks not that simple in the beginning. See, but actually it's not difficult. So this is very good example. Now, let me put my own experience, okay? When you deal this kind of integral, if these are symmetrical, no, from negative to positive, same thing. If this function is an even function, and that can be changed for by letting this negative. X equal negative t, then you solve the problem. Okay. Thank you for your watching.